webinar today. My name is Miriam Gangi. I'm in charge of communication and press office of ANFIA, the Italian Association of the Automotive Industry. ANFIA is one of the 11 partners of SURE5.0 European project. This project aims to support European SMEs to advance in their digital transformation while becoming more resilient, human-centric and sustainable. This project mobilizes 2.6 million euros in EU funds, and these funds are dedicated to finance the Industry 5.0 projects of European SMEs coming from 3 different industrial ecosystems: the ecosystem of automotive transports and mobility, the ecosystem of aerospace and defense, and the ecosystem of electronics. So today we will talk about virtual reality and cybersecurity that in the present landscape are 2 actual pillars for innovation and security for companies. Virtual reality is capable to revolutionize the operations, the industrial operations, and also offers immersive training experiences, while cybersecurity measures are very important for manufacturing firms to safeguard sensitive data and systems against evolving threats and cyber attacks. But let's go quickly through the agenda of today. We will start with a speech from Simone Luca Pizzagalli from TALTECH. TALTECH stands for Tallinn University of Technology, and this is the sole technology university in Estonia. Also, TALTECH is one of the 11 partners of the SURE 5.0 project. Mr. Pizzagalli will deal with the idea of mixed reality, a sort of continuum from the pole of real environment to the pole of virtual environment, and he will explain us the virtual reality applications for operation of heavy machinery, but also for remote operations and for fastening learning processes through the training with digital twins of real machines. And then we'll examine also some criticalities linked to this topic, like privacy and cybersecurity concerns. After that, we will have another speech from Alexander Kreppein from Fraunhofer Institute for Production Technology, and he will talk about cybersecurity for manufacturing companies, stressing the fact that many times inadequate cybersecurity measures are the main obstacle to advance in digitalization processes, in particular in small-medium enterprises. And he will also explain us the defense in-depth strategy. Finally, we will have a final speech by Enrico Frumento, representing here CYRUS Project, which is a European project focused on enhancing cybersecurity skills in industrial sectors and giving personalized and adaptive learning experiences. So he will compare the human side and the technical side of cyber attacks, and will also talk about the interdisciplinarity of competencies in this field. So I think we can start. I would only remind you some simple rules during this webinar. Please keep muted your microphone and switch off your camera in order to save Ben. If you have some questions, you can put them in the chat, write them down in the chat, Zoom chat, and we will have a Q&A session at the end of the webinar. So enjoy this webinar, and let's start with Simone Luca Pizzagalli.
Yes, thanks a lot, Miriam, for the introduction. And yeah, I'll just get straight to the point then. So good morning, everyone, and thanks for joining. And as Miriam said, today we'll talk about mixed reality. So not only virtual reality for the operation of heavy machinery. I have some use cases from our university, but I'll explain a bit further on the go. So let's first introduce like generic concepts of like what is virtual reality, what is augmented reality, just to have an idea of this. So virtual reality, I won't ask you anything, but it's like this set of immersive displayed input technologies which create the feeling of being present inside a computer-generated environment and could be very well immersive. So using like these head-mounted displays or making use of even a desktop would be also the same. Augmented reality is what set of technologies which allow to project and to visualize virtual objects on top of the real world. But most importantly, XR, so the combination of VR and AR and all the definitions in between, let's say, the real environment and the fully computer-generated environment, is that basically these are high-end human-computer interface, should work in real time because the experience of the user within the virtual environment, or in any case in the interaction with the augmented object, should be as fast as possible, or at least as much as possible similar to real world interactions. And in that sense, point 3 makes sense because the interaction should happen through different sensorial channels. So in this sense, it should be targeted to multimodality, which is actually one of the biggest, somehow also technical challenges for these technologies. How can we visualize this? It was called continuum between real environment and virtual one. There are different steps. There are different moments in that. So we do have a real environment, which is our everyday world, which we know very well how we interact with and how we perceive and move around. There is an augmented reality one where real world is still like predominant there, but we do have overlapping of informations that can be three-dimensional objects, but also like even data visualization or anything else that you can interact with through, of course, some visualization technologies, which can be augmented reality glasses, or can very well be just, you probably tried yourself with your phone, or tablets are also working on this sense. And then we have augmented reality, augmented virtuality, I'm sorry, where actually we are in a virtual environment where real objects are included. And I've been recently in a conference where they showed like teleoperation of a robotic arm. And actually the person would just visualize a twin of this robotic arm as a virtual environment, but still being able to interact and visualize the real controllers, joysticks of it. So this makes actually the interaction more comfortable with some objects and more natural, as we would do in the real environment, because also the perception, it will be like mixed. And then we have a virtual environment, which is a fully three-dimensional generated environment. And basically what you see here also in the images, there is this like application of like watching down a tower, how will you see it in virtual reality? So basically what virtual reality gives, it creates the illusion that you are basically in step 1, so in real world, when actually you aren't, through these sensorial inputs, which are mainly now visual and audio. But of course, there are a lot of projects working on including more and more let's say, the person, the human, into this environment, and having also haptic feedbacks, for instance. But we said a mixed reality or extended reality. So XR, it's mainly an interface, human-computer interface, right? And in that sense, it's how it becomes important for industrial systems and, for instance, in the control of heavy machinery, which is the topic of the webinar, because it allows us to visualize this either in an augmented way or a completely fully virtual way, and then interact with these machines. So how does this work? So, I mean, the functioning of this interaction is a bit more complex than what we have in real world, right? So it's not like direct with objects, but we have actually an interaction that is through, that's mediated by some hardware, which are usually these head-mounted displays and controllers we always see, or augmented glasses or a mobile phone or tablets. And then we have an interaction which happens in the interface, which is the virtual environment or the augmented reality environment. And in this sense, it becomes much more complicated because somehow anything can happen there in terms of, I mean, of course, there are the physics are usually trying to reproduce like what's happening in real world, but type of interaction are much more extendable. And you have also the idea of having an avatar there, and of course, like a hybrid twin or a digital twin of the machine you want to interact with. And then there is like this industrial system on the other side, which is basically controlled through the interface. But what you can see here, and what is also the point of Industry 5.0, is that the operator is present within the interface itself, which is this virtual domain, together with a hybrid or digital twin of the object he wants to interact with. I will show you now how, I mean, a few really small examples that were developed here in TALTECH by either master students, PhD students, myself, and other colleagues on several of these interactions and how they happen, and how these can be applied to either operation of this machine or the training, of course, and also like teleoperation of machines. Let's go through first what are the opportunities of having this immersive interface to machines or industrial systems that allows even the operator to be there present. Basically, one of these is the fact that it's safe, because it allows you to interact with the machine without even actually being in contact with the machine, but just with the twin of the machine. And in that sense also, especially with older robots, to not have like problems of even being distanced from the machine in terms of security. It allows remote operation when accessing difficult environments is difficult, actually, and in harsh conditions, and we all know like how drones are teleoperated in this sense. It allows like a training with digital twins on real machine, because it creates like use cases for the training which are always the same. So it optimizes repetitive procedures and it fastens the learning process even before getting to the real machine. This is true also here in TALTECH with some small application with students and 3D printers, for instance, like Meta 3D printers. It allows also to create a test bench. So in this sense, again, repeatable use cases, experiments, or easier data collection, and also safety for human-robot collaboration and human-robot interaction to determine what are the best metrics to evaluate this and how to optimize the processes. And of course, like as in the previous diagram, it includes the operator in this digital twin loop, allowing to, let's say, get back to design of these interfaces and the systems themselves in a more user-centered approach, with a more user-centered approach, which includes also the human within the industrial system. So we do have like a small visualization of this, I mean, like fully automated system on top left, and like older methods of controlling robotic arms, like in the center here with teach pendant, or more advanced like human-robot collaboration, where actually the human is next to the robot, and also like how VR can actually improve the teleoperation of robots, both, for instance, in space or like in terms of, for instance, surgery applications. So what's the first example here? First example is a small application that just shows you how the human should be included in the virtual environment and how this can be also easily made possible by just using normal cameras. So this was an application created by a student for a master thesis, where he actually created the tracking of body posture of the operator just through camera and machine vision techniques to include actually the operator in the systems. Now advanced headsets have already like cameras embedded in the headset itself, and they actually allow to hand manipulation, so to track the hand position and interact with the virtual or augmented objects for that sake directly with your arms. But in that sense, it shows you also, I mean, it's possible to do it also on this level. Another example is leveraging virtual reality to have more natural controls of the machines. So this is a robotic arm you have in the laboratory, and the student basically created an application to, it's a little bit small probably, but on the bottom left you see, to either drag directly the end effector of the robot with the hands. So you see the hands are tracked by the headset, and it can actually manipulate the position of the end effector. Or he included some simple hand gesture, so thumb up, thumb down, and etc., to give simple controls. So stop the motion, start the motion, whatever it is. And having, in that sense, a much more natural interaction with the machine itself without per se using teach pendant, which can be kind of hard to learn and to control. Other example, it's using augmented reality. So I'll just stop it for a second. Here it allows, this application allows like for teleoperation of the robot through a small, really simple augmented reality application and interface, which is based on, as you see, like image targeting. So the augmented contact is placed in the real environment through targeting the QR code in that sense, or the image. And then the robot can be controlled through the small interface here, which can be moved around and replaced by just using hand gesture, which was developed for HoloLens 2. And probably the most interesting part, you see the robot moves, there are some hints, and of course, like there are many more, let's say, improvements to the application that can be done. But the interesting part, and I will just go through a bit faster because the video is long, it's how it allows you to teleoperate the robot. So in this case, you see both the real and virtual robot at the same time. But it's also interesting how it works. And this was done on the spot in the same, and this is the same robot you saw before. Of course, like there are many issues also about how the movement is lagging here from the virtual and the real one. And this is also another example, and this was made possible with the, I mean, it's a different architecture, software architecture than the previous one, and it's also a more advanced, I'm sorry for this, interface. This was meant to create simple path plans for the ABB robot that you see in the bottom left monitor screen. So the application allows you in VR to create some simple path and to control the robot and run the routines of the robot. So this could be implemented, for instance, for welding procedures or other kind of works that the robot have to do. The interesting thing is you see like everything happens through hand manipulation. So in this sense, I was creating path points by just dragging this small sphere there and pressing the button, and you see again headset tracks the position of the hands, and the interaction is much more natural than teach-pendant. The idea is also including several robots in the same interface so that you would be able to swap from one to the other and control different machines. It hasn't been done yet. And then you can see we kind of successfully teleoperated the robot from the Netherlands to Tallinn. So you see, like on the left, the robot is in the laboratory in Tallinn, and we were actually in a conference there. And that was just, yeah, how it worked. So what are the criticalities here? And I'm gonna conclude also the presentation here. The point is that implementation of these extended reality software applications and interfaces are quite dependable on the hardware technologies and software architectures. So, for instance, you saw different teleoperation of two robots, which are based on different architectures, different headsets. The newer headsets include hand manipulation, which is quite efficient. So you can actually avoid using the controllers, the physical ones, but it's still not the best, for instance, but I'm sure like they will improve. There are no actually human-robot interaction standards using XR. So in real-world use cases, this is quite an undefined domain, and they are quite much use case dependable. So in every time you'll have to somehow think about, I mean, there are no standardized packages that can be reused for creating always the same, let's say, environments or interfaces. And of course, like it creates more and more like privacy and cybersecurity concerns, especially if the operators is included in this domain and maybe is tracked. So his position of the body position postures are tracked for some sort of security reasons, for instance, not to, you know, like get too close to the robot or whatever it is. And another thing is the assessment of these interfaces, which can be heavy somehow on the operator, especially if having to wear like headsets or glasses, is quite difficult because, I mean, you have to do tests and you have to assess on the larger amount of operators somehow, and it's also not standardized. So also in, let's say, scientific domain, you see different kinds of approaches to this and different type of metrics. We can be like just based on let's say, data collection of or biometric data, or even just using of questionnaires for this. And that is it from my side. So I hope that was interesting for everyone and on time as well, I hope. So yeah. Thanks a lot.
Sure.
I'll stop sharing my monitor.
Yeah. Thank you, Simone. It was very interesting, in my opinion, to see some concrete applications of virtual reality, since these technologies will probably become more and more crucial for shaping a secure, efficient, and resilient business environment in the coming years. So now let's pass to the second speech. So Alexander Kreppein from Fraunhofer Institute for Production Technologies will talk about cybersecurity for manufacturing companies. So please, Alexander, the floor is yours.
Thank you, Miriam. I'm now sharing my screen, at least I hope. Please quickly confirm that you can see the screen.
Yeah, we can see it.
All right. Thank you, Miriam. Yeah, as you said, my name is Alexander Kreppein. I'm a research fellow at the Fraunhofer Institute for Production Technology in Aachen. And the first question I would like to ask, why is an Institute for Production Technology talking about security? And we're going to have a look into this on the next slide, because we see a big discrepancy. On the one hand side, we see huge potential through digitalization. There are companies out there, they want to put a price sticker on digitalization, and one of these companies estimated the potential just for Germany, just by the year 2025, to be 126 billion euros. The number itself maybe is questionable, but what I want to point out is the potential that they are seeing just through digitalization, just for manufacturing companies in Germany. And on the other hand, what we experience and see quite often is when we go to companies and when we talk to companies, the digitalization rates are quite low. So the question which we are asking ourselves are, why are companies not trying to digitalize more at the moment to get part of this big potential that they have? And one of the answers that we often hear is that they have cybersecurity concerns. So this is why we said here cybersecurity is one of the main obstacles, because very often we try to introduce digitalization technologies and companies say, it sounds great, but we are afraid because of cybersecurity issues. And we can show you, or I would like to show you why this might be the case, and of course why they are not wrong. And to show the examples or give a little hint why this is a relevant topic to talk about, I would like to distinguish between IT, so information technology that we are working on with every day. For example, the email communication in our offices, the laptops, the file sharing systems, and so on. And the difference to operation technologies, OT, which is the machine equipment, the PLCs that control the machine, the computers in the production, those kind of equipments. And when we look at them and when we compare them, we see quite a big difference. So for example, I would like to point out just a couple of examples: antivirus systems. I think it's standard nowadays in every IT environment. And I'm assuming you're all on your laptops right now, and I'm assuming all of you have some kind of antivirus protection on your device. When we look at equipment on the OT side, this is rather rare. It's sometimes even not possible because the hardware is quite old and the performance is not strong enough. Another aspect is security and development. Nowadays, this is standard in IT. So every product, every piece of software gets tested for security problems. Not the same in OT. This was historically not considered. Nowadays, companies are starting, of course, to consider it more and more, but historically it was not considered in most or in a lot of components. And one of the biggest obstacles I would like to point out is the technology lifetime. In IT, I would argue normal laptops, normal cell phones, they're around for 3 to 5 years. In OT, this is different. OT is usually 10, sometimes even 20 years. And very often the equipment, the PLCs, the computers that are in the OT environment, they are not touched at all during this time. So what leaves or what was left now is we have older equipment often, which is not touched. We do not have security updates often. And of course, this is a security risk. So the next slide is probably not surprising to see, because we looked at the vulnerabilities of OT systems and we distinguished the OT systems on different levels. So on the top level, we have classical IT infrastructures. So for example, here, the printers that I talked about before, the IT level computers. And compared to OT, the vulnerabilities are quite low. And when we now go in lower and lower architectural steps, we see that the vulnerabilities are increasing, and especially on the supervisory level, there are quite a lot of problems when it comes to security, and you can find them out yourself. For example, you can there are special search engines where you can look for equipment that is connected to the internet. And it's quite easy to find them online. And of course, they are being exploited. And we can see this in the next slide in one example. And this is just one of many examples that are happening every day. This example here is from an aluminum manufacturing company, quite big, operates in 40 countries. And they were attacked from cyber attackers. And they had quite a big impact on them. So quite a lot of money that they lost, quite a lot of computers that needed to be exchanged, and even factories that were shut down. And now people could say and think, well, the big companies might be affected, and then I'm a smaller company, I'm not affected. That's actually not true. And to understand why this is not true, we have to think about the attacker side. And what the attackers are mostly after is money. It's not a often they try to get money, and this is a business model for them. And they are operating like a modern business, and they are trying to find companies where they can get the most revenue from. And then they look at the security levels, and if smaller companies have a lower security level and it's easier for them to attack them, they will do this because then it's easier for them to get in and get money. And classical attacks that we often see, or when we talk to security experts, that they often talk about are ransomware attacks. So often companies try to get access into security in your architecture, and then they encrypt all the data, production stops, operation stops, and then they ask you to transfer Bitcoins to their accounts, and then they decrypt your files. And if you don't trust them, they send you reference of previous companies where it worked. So they're actually quite well organized and operate more like a business, and want to get money. So now the big question, how do you protect yourself? The frustrating answer is it's not an easy task, but the good news is there's some help. There are norms and standards, but what they all have in common, they usually see security as a management task, and they do not see security as a one measure that you just need to implement and then everything's fine. It's a little bit more complicated, I'm afraid, because it affects several layers of an architecture of the company, and these norms and standards can help you with them. One of the principles that they introduce is a defense in depth strategy. You have you have your assets in your company, and the idea is to build defense layers around this assets. So for example, there are network security, so I would say classical classical network security components, but also there are human security levels. So for example, the human itself, which needs to be trained. And then there's the management level on top. So for example, prevention plans that need to be established. And of course, on the lowest level, you have lots of different kind of security measures that depend on the assets. So the main takeaway I would like to give you is considering security when you introduce digitalization, but I would also ask you to not be afraid to introduce digitalization, because there's help how to protect yourself from companies. So I hope that we will see lots of digitalization in the next years, but in a secure way. And with this, I would like to end my presentation, and thank you for the attention.
Thank you, Alexander, for the interesting presentation. It's quite incredible how cyber attacks are underestimated, often underestimated, even if we have so many cases around the world. And now let's conclude our webinar with the last speech by Enrico Frumento from CYRUS Project. He will talk about rethinking cybersecurity and cyber risks from the human element point of view. So I'll give the floor to Enrico.
Hi, everybody. Can you see me? Can you see my screen as well?
Yeah, we can see it. Thank you.
Okay, fine. Thank you. Welcome, everybody. So the title of my presentation is just a little bit different. Still talking about cybersecurity, but talking about the cybersecurity from a different angle. That is the angle of the human element. Because one of the things that we saw in the two previous presentations is that the role of humans is important. First of all, humans are still in the loop. I mean, are heavily still in the loop, especially talking about the VR. And from the cybersecurity point of view, one of the things that is to keep let's say, well present is that the humans are involved in the definition of the cyber risks to which the OT systems are exposed. Because one of the things that have been said before is that one of the things that distinguish the OT security from the IT security is the long-lasting operating time of the technologies. We are talking about 10 to 20 years of operating. So this means that these technologies are not changing that much in that period of time. One of the other things that is not changing that much in the even longer period of times are the humans, because the humans are always more or less the same, they are always involved. So we are speaking about a scenario that is becoming interesting from the cybersecurity point of view, because there is one thing that is important, the social engineering. And the point is just, I would just introduce the problem telling you about two simple, let's say, recent situations. One is the Emonet campaign. Emonet is one of the most, let's say, prolific malwares appeared in the recent times. It affected mostly the banks, but anyway, affected other sectors. But the characteristic was that the campaign was a phishing campaign in which there was an email containing a password-protected zip file as an attachment, which contained an Excel file that contains the malicious macros. So think about the attack. To attack the system, you need to open the mail, follow the instructions, open the zip, copy and paste the password, open the Excel file, enable the macros, and forget that you have done everything you see here. So the point is that the humans are actively collaborating in the exploitation of his home terminal or machines. All these things must be manually done. So you can see that is a very peculiar problem. Another problem is, for example, just in another industry, the game industry, about the League of Legends that have been hit by a ransomware, which they refuse to pay. Most of the time, I would say 99% of the times, the ransomware means social engineering attacks that has successfully broken the, let's say, minds of human defenses and went through, for example, convincing the user to click on something. But at the end, also the Norsk Hydro, there is an error, Norsk Hydro case was ultimately provoked by a human error, because the source of the problem, there was a phishing mail which was successfully, let's say, successfully by the attacker's point of view, penetrated the defenses of the company. So there is a problem in cybersecurity that is about the humans. There is one thing that we have to consider. When we are dealing with the IT security, we are dealing with competencies and technologies built and to manage the security of the IT machines. When we are dealing with the OT security, we are dealing with competencies and technologies that are different from the IT security point of view and different competencies. So the point is that when we are dealing with the security of humans, we need a totally different set of tools, competence, methodologies. That is actually one of the frontiers of cybersecurity, and we will see it through this in a moment. So when did this problem begin? Probably with the Adam and Eve, which might be seen as one of the first, or if the first at all, social engineering attacks in general. But without considering this is just a joke, of course, the problem is around the humans, because the humans are not only, let's say, the humans themselves, but the humans when they are managed or, let's say, coupled with an actor like this, that is exploiting technologies, or rather than technologies, competencies to, let's say, fool or, let's say, deceive the humans in a way, and becoming the human be part of the attack strategy. So the point is that it is an element abused by almost all the cyber criminal, cyber terrorist attacks. around the world. There are relatively well-known statistics that says that 95% of the successful attacks have been provoked by human error. So we have a problem because the human is the system under attack. So the question that I pose is, which sciences contributed to modeling the attack systems? The IT systems, well, we know the OT system, we know which sciences and technologies are involved. But what happens when there are the humans at the center? The problem is this, that the humans are, let's say, studied, modeled, understood by all these different types of sciences: pedagogy, cognitive sciences, psychiatry, marketing, management, design, philosophy, and so on. The point today is that these type of competencies have been exploited by the cyber criminal attackers. Because one of the things that is becoming evident is that in the cyber crime underworld, these type of competencies are paid much more than, for example, the malware developers. There are studies in which there are, let's say, 500 times more valuable this type of competence than the technical competence, because of course this is a consequence of the value of this type of attack tactics. They are capable of producing 95% of the revenues of cybercrime. The point is that from one side we have 95% of risks provoked by social engineering, but on the other side we have less than 5% of organizations pay something specifically meant for securing the humans. And the same happens in IT and OT, because of course we have hardware. OT security is full of, let's say, hardware, software, but we also have another part that is the so-called wetware, the humans. This is a nice way to think about the humans from the security point of view. And the point is also, we know how to estimate the risks of hardware being attacked, or a software being compromised, or an IT system being compromised. But which is the cyber risks of a human being compromised? There are no clear models to model the human-related cyber risks, because the humans are provoking risks to the company. We just saw 2 examples before. And so, just to demonstrate how few the things are perceived by the market, the academia, the industry, this report have been published a few days ago by Hive System. You see, social engineering, the blue stripes, is one of the less explored, even in an academia, even in the industry, and in the news. So it is a problem, because on one side we have cyber criminals which understood clearly the value of social engineering and the attacking humans. On the other side, we have all the other worlds, industrial, academia, and so on, that still do not understand this. And for this reason, in CYRUS, and especially in CYRUS, we started to investigate the problem of rethinking the cybersecurity completely with having the humans at the center. Creating a sort of new branch. We are working in this direction. That is, let's say, covering these 7 macro pillars: the education, special education tracks, the vulnerability assessment and penetration testing. What does it mean to vulnerability assess and do penetration testings on the human elements? You have ethics, sociology, legal limitations, and so on. But anyway, it is a system that, as I said before, needs to be included in the assessment strategies of the company. What this means to use training as a defense instrument to reduce the cyber risk? What does it mean to do threat intelligence on the humans? What does it mean to simulate attacks on the humans because there are ethical and legal problems? What does it mean to have AI systems to assist the humans in cybersecurity, of course, and integration, lastly, the integration of the 3 sources of risks, IT/OT, and humans, in a unique cyber risk model. So this is a very complex, let's say, area of investigation. As Jeffrey, and I'm the cybersecurity research lead in Sheffield. We are investigating this type of things in the research programs of the European community. To concentrate on two things that have been explored in the CYRUS projects. The problem is that doing this sort of general rethinking of the cybersecurity around the human element, or from the human element point of view, it is mainly a multicultural problems, because we don't have only IT experts. We also have all these types of competencies that are not used to talk about cybersecurity, because IT experts are not used to talk about the cybersecurity of humans, and the others, cognitive scientists, psychologists, and so on, are not used to talk about the cyber security. So we have to, let's say, merge these two types of competencies and people that are not used to talk to each other. So it is a new opportunity by one point of view, and it's also a new opportunity for the education, because it needs to become a cyber risk reduction methodology. It's not only doing education just for doing it, because the ISO asks to do education, the regulations, or we have public funding for doing education and so on. It is something that is meant to reduce and manage somehow the cyber risks of humans inside an organization at the different levels, of course. Okay, so create an impactful, long-lasting learning paths. This is the aim. There are two sentences that I took from relatively old 2020 sentences that more or less goes in this direction. Especially the second one, third generation security awareness programs should be expected to become more effective with maximal use of creative multimedia training options. This means that we have to not only do more, let's say, immersive, more effective training, not just because we need to transfer competence, but because we need to change the behaviors of the persons. There is a broad range of security, which is called behavioral security, that is just concentrating on modifying the behavior of the persons to be more secure, of course. But this is just one aspect of including the humans in the cybersecurity. And the CYRUS project that I'm representing here today is composed by different partners. I am from Sheffield, and on the first row on the right, one of the things that have become evident talking about cybersecurity that is concentrating on manufacturing and transportation sectors. So the aim is to find a new training methodologies, a new training paradigm for manufacturing and industrial sectors. This is the general aim of the CYRUS project. One of the first things that the studies tell us is that traditional cybersecurity awareness and training do not work by the cybersecurity point of view. For example, one of the things that we've done in the project in the first year was to do a very long surveying or sampling of the training needs of different transplantations and manufacturing companies around Europe, and compare with the other studies in order to know which is the status of the current companies, which are the needs, which are the threats they are exposed to, in order to define the gaps in trainings that are currently needs to be filled somehow with a more effective way of training. That is the story of the project. So both of the things that have been underlined by the recent studies is this shown in the slide, that only 14 organizations set a long-term workforce strategy. That means that by the human element point of view, think about the skills shortage, something that is exposing the humans to cyber risks. Think about this. So that means that only 14 organizations are thinking about long-term risks of humans. Only 48 of organizations are currently struggling to find a higher cybersecurity professional. So there is also a shortage, not only of persons and competence, not only of competence, but also of persons. And the other part that is found by the other two parts is found by the project are really interesting because there is a huge cybersecurity skill gap, especially in sectors where the technology is mission critical. And we can say that OT is one of them. Worsening trend until 2020, 2030, whose effects are dooming today's cybersecurity landscape. And people do not have time to follow training. That is one of the problems that we are trying to solve somehow with the new learning paradigms that fits within the time constraint and tasks and work habits of the different persons. From a very, very high, I'm going to conclude, point of view, this is what we are trying to, let's say, build, but also it is the vision of CYRUS long-term in the evolution, because we are CYRUS is a research and innovation center located in Milano. So we are doing a lot of research in this area. And the pillars of the new, let's say, ways of training people are built around this. And the innovative authoring platform that is meant by different, for example, one of the most innovative things here is the use of andragogy, that is the equivalent for adults of pedagogy. This is something studied and described in the 90s that is coming today in the cybersecurity. So you can see we have a delay between what is applied in cybersecurity was studied in the pedagogy area of more than 30 years. So this is just one example of how few these different type of competencies are talking each other in the area of cybersecurity. So the personalization, the wide selection of learning paradigms, the profiling and dynamic clustering of learners. Here, for example, this is the importance of data analytics, learning analytics, and AIs to create the classroom or the clusters of trainees that are exposed to the same risk, for example, and then to deliver highly personalized and adaptive learning experience. This is the general concept of the project and of what we are doing in CYRUS. But anyway, for the context, I would leave my slide with the LinkedIn and the link to the CYRUS project as well. And that's all from my side.
Okay, thank you very much, Enrico, for your presentation. Also, in this case, we can say that there is a sort of underestimation of human errors, human vulnerability, and I can confirm that it's very difficult to change human behavior in companies, much more than changing technical procedures. And so we discovered that cybersecurity is really a human-centric topic, and there is a great need to call attention to this specific topic. So now let's check if we have some questions. If you have some questions, I remind you, you can write them down in the chat of the webinar. And if there are no questions, I can pose one question to Simone Luca Pizzagalli. Since you showed us some criticalities of virtual reality applications, could you give us some examples of how one or more of these criticalities could be overcome in the next years?
Well, yes. For instance, one way would be, of course, like the fact that this application would be widespread. It would help defining more standardized tools, either for the implementation of XR interfaces or controls or whatever it is, and secondly also to assess, like to find like metrics to assess both their impact on the operator user, but also the efficiency and also medium and long-term revenues of the technologies, or like how they would, let's say, pay back on medium and long-term on like training or whatever application there are in the industry. But I guess like now there should be like a more standardized set of tools that would allow a more uniform definition of use case needs, technologies, software packages, and interoperability with other systems, because every time now it's a different use case, and somehow it's not like starting from scratch, but almost. So also the other examples I saw recently in other conferences, it's more or less they are kind of talking about the same topic with different tools. So that would help a lot, I guess, now.
Okay, thank you very much. I can see questions in the chat, so I will pose another question, if it's possible, to Enrico Frumento. You showed us a new approach, a human-centric approach to cybersecurity. Can you give us an example of a concrete case in which this new approach was applied and get some results in improving cybersecurity assets?
Yeah, cases. I've been working on this social engineering area since more or less 15 years. So there are hundreds of cases, but one of the things before this that I can mention is the Dogana project, which was lasting for 3 years and have been granted by 5 million funding. In that project, we concentrated on defining the evolutions of social engineering and the ways of testing legally and ethically in a correct way, right, at both point of view, the humans with simulated phishing campaigns. Nowadays, it's one of the things that is commonly applied, simulating the phishing, but one of the things that the companies forget most of the times is that you are going to fool somehow the persons to make they seems to be, let's say, falling in errors. And this is ethically, if not even legally, not acceptable. So the point is that you have to build a process that is acceptable by those 2 points of view. And of course, it is also able to give concrete results in terms of estimation of the cyber risk. Because it is not only a way of creating a wall of shame. You fall in a phishing, so blame on you. That's not the way to proceed. No. And the point is that the estimation of cyber risks need also to consider the type of assets that the person are managing. So if it's a person with limited assets to the assets, it is one story. If it's a person that went through the let's say a different training tracks and so on, is another story. So even to consider the personal, let's say, characteristics, there are some persons that are more or less fails than others. Okay. And the other point is that to link all these things with the training platforms to create a sort of loop, train, measure the risks, perform other simulations, and so on, looking that the risk somehow diminishes in a way or in time. Yeah. That is one process that we applied 2 days. We tested as Sheffield more than 1,050 persons in several companies. And what the things that we see is that the risks represented by the persons is diminishing, but very, very slowly.
Yes, thank you very much. So there are no questions in the chat, so I think we can close here our webinar. So thank you to everybody for being present here today. I would remind to all people interested that the documentation and the recording of this webinar will be available on SURE5.0 website. So SUREproject.eu is the URL of the website. And so thank you, have a nice day, and see you to the next webinar. Thank you. Bye-bye.
Thank you very much. Have a nice day and have a nice holiday.